Hello everyone. Today I will show you how to make a PID line follower in EV3 using Small Basic. So first the demo. For this program you need two motors at each side of the robot. In my case I have connected them to ports B and C, and you need two color sensors in the front of the robot. I have used high technical color sensors, but EV3 sensors will also do. I have connected them to ports 1 and 4, but if you have connected them to any other port, you can change the port number in the code. So the robot has two sensors which lie on either side of the line. When the robot sees entirely white, it knows the line is in between, and so it can go straight. But as soon as one of the sensor detects a fall in its value, that means it has detected black. So the robot is now on black, and it needs to make adjustments so that the line is exactly in the center again. This adjustment is made by the code, which decides how far to the left or how far to the right the robot currently is and how much it should adjust. So let us now take a look at the code. PID stands for proportional, integral and derivative. In the code, each term is multiplied to its own constant. For proportional, it is multiplied to Kp, integral Ki and derivative Kd. Proportional, which will react to the changes happening in right now. The integral is the sum of all the past errors, and it reacts on the basis of the values it has received. And the derivative tries to predict the next error and tries to prevent it from happening. This is the code for the PID line follower. First, we set both the sensors to reflected light intensity mode. Then we define the Kp, Ki and Kd values. We define the power at which we want the motors to rotate, and then we reset all the variables. So inside a while loop which goes on for infinity, we read the sensor value at port 4 and at port 1 and store them in two different variables. Then we receive the error of sensor value minus sensor value of port 1 and 4. Then the integral term is calculated using integral plus error, which means that every time the loop is executed, the error will be added up to the integral variable and it will be multiplied by 2 by 3 to soften it. Then derivative is equal to the error minus the last error. As I told you, the derivative tries to predict the next error. So the turn is calculated by using each of the proportional, integral and derivative terms and multiplying them to their own constants. So the turn is calculated as Kp into the proportional term, that is the error, plus Ki into integral plus Kd into derivative. Then the motor speeds are defined as motor speed A is equal to speed plus turn and motor speed B is equal to speed minus turn, and we set the last error as the current error for the next execution of the loop. And then the motors are started with these respective powers. The Kp, Ki and Kd values differ from robot to robot and can only be set using trial and error method.